Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the problem number of islands 2, and it's a problem which is kind of an online query problem. What do you mean by online query? I give you a query, you tell me the answer. I give you a query, you tell me the answer. I give you a query, you tell me the answer. I give you something, you do some changes, you tell me the answer. The changes, what you need to do, I will tell you. Okay. So every time give you something, you do the changes as according to the question, and then you return the answer. So give answer, give answer, give answer. That's what you call as online queries. Okay. So this is the part 2 of this problem. I've already solved part 1 in this particular series. You can go back and watch it as well. So the prerequisite for this video is disjoint set data structure. I've already discussed this in the previous video in this particular graph series. Just in case you don't know about it, go back and watch it. The reason I'm asking you to go back and watch it is because I'm going to reuse the snippet of the code that I've coded in the disjoint set video. Okay. So let's understand the question. 0 is C, 1 is island. Keep it in mind. Okay. Initially, all are like we have an entire C. Someone comes up and says, hey, can you create an island at 0, 0? I'll be like, okay, let me create an island at 0, 0. So you just create an island at this position. Okay. Now remember, what do we mean by components kind of this? So if I have 1, 1, 1, it's a component. If they share a similar side, they can share a similar this side, this side, this side, this side. You can't say these two be connected because they are sharing a diagonal. No, they have to share a side. Okay, you'll understand as we move. So as of now, we have a single component. So after the placement of the first guy, the answer is 1 because I just have a single group of islands, a single group of islands. Okay. The next guy is 0, 0. But wait, we already have an island there. So there's no need to place the island again. Thereby, we still have one island. So remember this, if there is an island already, you do not place another island. Okay. Next, 1, 1. So let's place an island there. 1, 1. Now, can I call this as a group of islands? I said, they're individual groups. They're individual groups. So we have two groups after this placement. So we have two groups after this placement. Perfect. Next, 1, 0. Where's 1, 0? Here. Let's quickly place it. Now, this and this share a side. This and this share a side. So this is a single group. So after the placement of this, you have one group. Nice. Next, 0, 1. Where's 0, 1? Here. So you can place it over here. Now, if you see this, it's a single group. So you still have a single group. Amazing. What's the next? 0, 3. Go ahead and put it over here. So this time, can I say, I have one group over here, one group over here, because in between there are C's. You cannot connect them because they need to share a side. Thereby, we have now again 2. Next, we have 1, 3. Where's 1, 3? Here. So can I say, even if I put it here, it's still going to be the same. It's still going to be the same. So thereby, I can say, hey, listen, it's still having 2 group of islands, which is pretty decent. 0, 4. Where is 0, 4? Which is here. So even if I place it here, remember this, even if I place it here, it's still going to be in the same group. If it is still in the same group, can I say, it doesn't matter to us, it's still in the same group. So thereby, I still have 2. Perfect. Next, what? 3, 2. Where's 3, 2? Here. Let's quickly place it. I place it. The moment I place it there, can I say I have now 3? 1 here, 1 here, and 1 here. Yes. Next, I have 2, 2. Let's place it. The moment I place 2, 2, again, this is separate, this is separate, this is separate. Be very careful because you cannot connect them diagonally. We still have 3. Next, 1, 2. Okay. Now is the point. The moment you place it here, everyone is an individual group now. So it's 1. Right from 3, you boil down to 1. Right from 3, you boil down to 1. Next, we have at 0, 2. Where's 0, 2? Here. Even if you place it here, it still stays as a single thing. So you still have a single thing. So I can say I still have a single thing. So ultimately, you need to return after first query. Answer is 1, 1, 2, 1, 1. So you can put them into a list, and this is the list you have to return, the online query list. This is what you have to return, right? Understood the question? So how will you solve this problem? Which algorithm to use? Can I say, what are you doing? you're first placing here. Then maybe you're placing. Then you're placing here. And when you're placing somewhere here, you're connecting. You're connecting. Right? And then you're placing here. You're connecting. Then you're placing here. Then you're placing here. You're connecting. Then you're placing here. You're connecting. Then you're placing here. Then you're placing here. You're connecting. You're connecting people. You're connecting cells. You're connecting nodes. Which algorithm? You got it right. Disjoint set data structure is the algorithm which will be used. Why? Because that is the only algorithm which connects, and is used in dynamic graphs. It's a dynamic graph. It is changing every now and then. So, dynamic graph, connections, there's only one data structure. That is the disjoint set data structure. So, in disjoint set data structure, we have nodes. The zeroth node will be the parent of himself. The first node will be the parent of himself. The second node will be the parent of himself. So on till n nodes. So if we are representing every cell as a node, you have to give every cell a number, which will be represented in disjoint set. So can I say cell 0, cell 1, cell 2, cell 3, cell 5, cell 6, cell 7, cell 8, cell 9, 10, 11, 12. Can I say I can go on till 19, which is kind of like 4. This was 4, which is m equal to 5. This was 3, n equal to 4. 5 into 4, like we need like 20 positions because 0 to 19 is 20 positions. Can I say it's like n cross m? But how do I figure out? Because this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How do I figure out 11 is representing 2, 1? How do I figure this out? Or vice versa. 2, 1 means 11th node. How will you figure this out? Now, very, very easy. Every column has 5 nodes. This column has again 5. So 5 plus 5 till here will be 10 nodes. Because first column will consume 5 nodes. Second column will consume 5 nodes again. So when you are at the third column, which is the second index, can I say 2 into 5, the previous 2 columns would have consumed till here 10 nodes, which is very obvious. They would have already consumed 10 nodes, which is nothing but 2 into 5. 2 is the row number because it is 0 based indexing. Previously there was 2 rows. So 2 into 5, 10 nodes have been consumed. Now I'm looking for the first position, which means you got it? Which means 2 into 5 plus 1 will give you 11. Because if you're like 9, this will be 10, right? Because very simple. And this will be 11. So because if you're looking at this, it's a plus 2. If you're looking at this, it's a plus 3. It's a plus 4. So can I say the formula to compute the node, the formula is very simple. Any row column can be said as row into m. Why m? Because every row has 5 guys, which is nothing but the column length, right? So can I say row into m plus the column number is what the node ID will be signified, or the node number will be signified. So you figured this out. Very simple, right? Before implementing disjoint set data structure, remember one thing. If there are multiple same cell numbers, you don't mark it again and again. Remember? So what you can do is, you can maybe use a visited array to keep a track that you do not reuse a cell number, because if you're getting twice, it doesn't make sense. Okay. So first thing, when you're starting off, can I say the initial number of islands are 0? I can, right? So the moment I have the first guy, I see, is it marked in the visited array? It's not. So I'll maybe mark it as true. Let's quickly mark it as true. So I marked the 0th guy as true. What is my next thing? Once I mark the 0th guy as true, my next thing will be to take this node 0, right? Take this node 0 and see if there is an island on the right. No. If there is an island on the bottom. No. On the left and the upper guys are not there. So apparently this guy himself will contribute to the island. So the count will increase, and it did not have anyone on the right or on the bottom. So it could not get connected to the other islands. Perfect. Next, I have 0, 0. I see this is already visited. So I'll say, hey, the count will still be 1. So see, first we got 1. Now the count still stays at 1. Next, we'll go to 1, 1. The moment we go to 1, 1, we are like, it's not visited. So let's mark it as visited. And now let's look at its, is there an island? No. Let's look at it. Is there an island? No. Is there an island? No. Is there an island? No. So no island. So this guy himself contributes one to the answer. So I increase the contribution to two. And I can say the answer till here will be two. And I'll mark it as visited. Perfect. Next will be 1, comma 0. This is where the twist comes. 1, comma 0 is this, which is unvisited. So first, mark it as visited, right? That means it's an island. So we have an island here, right? Imagine this 1, comma 0 would have contributed 1 to the answer. Just imagine. Would have contributed 1 to the answer if it was not surrounded by anyone. But now I'll look at the surroundings. I'll be like, okay, the answer is 3 till now because it was not surrounded by anyone. I imagined when I got this island. Now this guy looked at the front, top, and said, hey, I can go and connect with you. If I can go and connect with you, I myself will no more be an answer. I myself will no more be a single individual island. So maybe reduce, like, okay, reduce, fine. So I'll now have the connection between 0 and 5 in the disjoint set. I'll just ask them to connect 0 and 5 and they'll get connected, right? Next, I will look at the right and I'll have another guy. I have another island. Okay, I'll also connect with this guy. So this will also reduce to 1. Why? Previously, it was 2 individual guys. This guy connected to this, reduced them by 1. Again connected to 1, reduced by 1. So it eventually connected 2 guys. So the reduction will be 2. He himself got +1, but he actually reduced 2 guys and made them connected. Got it? Simple. So the answer is 1. The answer stays us to be 1. 1, comma 0 is done. Next, 0, comma 1 is this guy. Let's mark it as visited. And imagine it is alone. And increase the value by +1 to 2. Now let's see. This guy says there's no one on the top. Like, okay. There's no one on the right. Okay. And there's someone on the bottom. Remember this, there's someone on the bottom. So I'll be like, can I go and get connected with this guy? I can. Because we were not connected previously. We were not connected previously. So if I go and connect with themselves, I'll reduce my answer to by 1. Right. Next. This done, this done, this done. This. Okay. Wait. I can connect. But will it make sense to connect? Aren't they already connected? And the disjoint set will say, yes, you guys are already connected. So what's the point of connecting here? What's the point of connecting here? You're already connected via this. And if you find the ultimate boss, you'll find the boss to be 0 for this as well as 0 for this. So there's no point in connecting. So I'll not connect. Thereby it still stays as 1. If you're not connecting, keep the answer as it is. Perfect. Next, 0, comma 3. Where's 0, comma 3? It is here. Mark it as visited. Does it and increase the answer by +1. Increase the answer by +1. Why? Imagine itself to be alone. Imagine itself to be alone. Does it have anyone on the top? No. Does it have anyone here? No. Does it have anyone here? No. Does it have anyone here? No. So you consider himself to be alone. Yeah, that +1 worked. If it would have got connected to someone, minus what would have been done. But since it has no one, the +1 stayed and you got an answer as 2. Perfect. Next, 1, comma 3. Where's that? Here. Mark it as visited. Increase the answer by +1. So eventually, like initially, individual. Connected. We can go and connect. The moment you connect, reduce. Can you connect to the right? No. Can you connect to the bottom? No. So the answer is 2. It actually makes sense. Next, 0, comma 4. So let's analyze 0, comma 4. It's here. Again do the same thing. Increase the answer by 1 and mark it as visited. Now, top, no. Can I connect? Yes, they're not connected. The moment you connect, reduce the answer by 1, 2. Perfect. Next, 3, comma 2. So next is 3, comma 2. So let's go to 3, comma 2 and mark it. Again, increase the answer by 1. Considering itself as individual when it came. Does it have anyone at the top? No. Does it have anyone on this? No. On this? No. On this? No. On this? No. So we consider itself as alone and that worked. Thereby the answer for this will be 3. Perfect. Next, 2, comma 2, which is this. So consider itself to be alone. Increased. But the moment it saw, no. No. But the moment it saw it downwards, it found someone to be connected to. Already an existing guy. So it gets connected and reduces the answer. Makes sense? Gets connected to another island. So why will it be considered individually? Right? What's next? 1 comma 2. Very, very, very important. You have to understand this. Once you understand this, you understand everything. Okay. 1 comma 2. Where is that? This is somewhere here. Right? So what I do is I'll be like, okay, let's consider this as an individual. Let's consider this as an individual. So the answer should be 4. Answer should be 4 if individuals should have been considered. Should have been. But we will now start connect. Can it connect to the top? No. Can it connect to the right? Yes. Go and connect. Connected. Answer reduced by 1. Can it connect to the bottom? Yes, they're not connected by any means. Nice. Answer reduced by 1 more. Can it connect to the left? Yes. Go and connect it to the left, which is this. Answer reduced by 1 more. The answer is 1. And mark it as visited. Nice. So if you see, everyone got connected and it reduced 3 and it just did a +1 for himself. So eventually it's a +1. Got it. Nice. So we have 1 as the answer. Next is 0, 2. This is this. So you say visited and you increase the answer by 1 because for himself, just in case it doesn't get connected to anyone. Now, no, it gets connected to this guy and says, I've reduced myself by 1. Next, the moment it tries to get here, it is already connected, finds it's already connected. So there's no point in connecting here. It's already connected. So there's no point in connecting here. So the answer is 1 over. And this is the list that you can easily return. Pretty simple. 4 directions traverse, just connect. And whenever you're connecting to someone, reduce -1. That's it. Pretty simple. I hope you have understood the entire explanation. It's time to code it up. So as usual, I'll be coding the C++ solution on the right, and you can figure out the exact similar Java code on the left. What do you require? Obviously, the disjoint set data structure. So let's quickly take it off. Okay, we will just get rid of all the functions. Okay, so disjoint set. Now, I need the size. What was the size, if you remember? Yes, n into m. Those were the total number of nodes. Quickly, let's have it. What's the next thing we require? We require a visited. So maybe we can keep it as this. And we can use the mem set, like visited 0 and size of visited. This will make sure everything is marked as 0. Initial number of count, maybe we can keep it as 0, saying that initial number of count of islands is 0. And we can have a list which will store all the answers. And at the end of the day, after performing the operations, we can return this particular answer. Now, I'll be like, okay, fine, we got it. What's the step? You have to go through all these queries. So let's go through all these queries. Now, I know one thing, the row will be IT of 0, right? I know one thing, the column will be IT of 1. And something I know for sure is if visited, like if this guy has previously been visited, like it's already an island. So it's not going to add up or delete anything from the answer if it's already an island, because everything would have been previously computed, correct? So what I can say is, hey, listen, there's going to be no change whatsoever in the count of islands. So you can just do it and go to the next query. Perfect. But if it is not, then I'll be like, okay, let's mark this as visited. And at the same time say, let's count it as an individual island. Then we can do the subtractions up, right, and everything. So can I say the upward guy will be row -1 column? Can I say upward guy will be row -1 column? I can. Row -1 column, right? So, and then can I say the right guy will be row comma column +1? I can. Can I say the bottom guy will be row +1 and there will be no change in the column, right? And can I say the left guy will be row comma column -1? I can. So if you see, I can either write 4 different statements or I can combine them into a dx and a dy, where, or you can say dr, which is the change in the rows and the change in the columns. Now, how do you figure this out? So if you see, it's a -1 on the row for the first time. It's a +0, it's a +1, it's a +0. So it's like -1, 0, +1 and a 0. So I just took the changes in the row. And then there is a change in column as +0 for the first time. Change as +1. change as 0, change as -1, if you carefully notice, right? So if you see column is -1 and we have a -1. If you see column is just column and it is 0 over here, column is +1, +1. So if you see -1, like this 0 and -1 will be the first guy. Then 0 +1, +1 0, and 0 -1. So I've already taught this technique. That's why I did not use the iPad. So index lesser than 4 and index plus plus. Can I say the new row? That means the adjacent row, or maybe you can say adjacent row, will be the current row plus the change in the dr, which is dr index, right? And can I say the adjacent column will be nothing but column plus the dc, the change, the delta c, right? So this is the new ones. I need to check the validity. It might be crossing the grid, right? So just make sure you check out the validity of this thing. So first, make sure is valid is what you will call. So go across and say adjacents are adjacent column and the n and m. Once you've checked the validity, then you can do the other things. So maybe you can write a private boolean function. Yeah, that's what I will do. Private boolean check, or rather is valid, and I will say okay, int adjacent row, int adjacent column, int n, int m. Okay, and I can say when will it be valid? If it is this, if it is this, if it is sorry adjacent. Oh, why am I writing adjacent? Adjacent r, yeah, and then it will be for column, adjacent column, and an adjacent column is lesser than m. Can I say it will be valid for this? So just return it. If this is true, it will go as true. If any of the conditions are false, it will go as false. So is valid will be checked via this. Once is valid is checked. The other thing I need to check is the adjacent guy actually an island? Then only I'll connect. So it has to be an island. So on visited, on adjacent row, an adjacent column, it has to be an island. If it is not an island, there's no point in connecting. Understood? So it has to be an island. If it's not an island, then I do not do anything. What after this? Check for validity, check for island. I need to connect them. But will you connect if they're already connected? I'll be like, no. So let's check for connectivity as well. DS dot, how do you check for connectivity? If their parents are same or not, right? Find parent of whom? You have to find the node numbers now. So can I say the node number, like the current node number will be row into m plus column? I can. And can I say the adjacent node number will be adjacent row into m, right? Plus adjacent column. Very simple. So I need to connect these two guys. So node number, if the find parents are not equal, very, very important. If the find parents are not equal, so you can just write this. Take the adjacent number. If they are not equal, can I say, okay, they're not equal. So we are connecting. Reduce -1, if you remember. And say ds dot. Call the union. Let's do some connections. Union by size. Whom will you connect? One is the node number, right? What's the other one is the adjacent node number. So go ahead and connect these guys. So once this entire for loop has been computed, can you say the answer will be stored? Because you will have the number of elements, and then you can go ahead and return it. This is how simple it was. Make sure you end the disjoint set and end it with a semicolon. So if you see the answer is coming fine, so let's quickly submit this and see if it is running fine. So all the test cases do run, but did you notice something? Look at the code quality. Look at the variable naming, and also see how I wrote like an error-free code. So these things are very, very important. If you look at all the other lectures on YouTube, they will not be having this level of code quality. They'll not be using a class of disjoint set. They'll probably be using a find union parent and inside the solution. This is something you should not do in interviews. In interviews, these things stand out, make you stand out apart from the rest of the crowd who watch all these crap motivational videos. This is where you can actually be like, hey, you gotta hire me because my code quality is of supreme nature. Got it? So make sure you focus on these small things, because these things do matter when you go for an interview. So before wrapping up this video, I have a very, very earnest request to make. please do consider subscribing to us. I did check out our statistics. Nearly 50% of the users who watch our video do not subscribe. So please do consider subscribing to us, because that is the only thing that keeps me motivated to make videos at like 3:24 a.m. in the night. So please, if you have watched the video till here, consider subscribing. Hit that like button. If you haven't checked out our DP series and the SD sheet, the links will be in the description. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye bye. Take care.
Whenever your heart is broken.